All right, let's take a look at example 5. We want to write sine of 3x in terms of sine of x. Well, we don't have a triple angle identity, so there isn't anything that we can just use for sine of 3x. But we could make it a sum identity. We could say sine of 2x plus x, and then we can use our sum identity to simplify that a little bit, or to expand that. So let's go ahead and do that. So we have sine of 2x cosine of x plus sine of x cosine, let's see, of 2x. All right. Now we have some double angles that we could use. We could maybe do some double angle identities here. Well, we know that sine of 2x is going to be 2 sine x cosine x. And then we still have that cosine of x there. And then we still have our sine x there. And we can change that cosine of 2x. Now we have 3 different options here. And so we've got a cosine squared there times sine. So if I use one that has cosine squared in it and then I multiply by the sine, that might help me out a little. So let's try the one that says cosine squared x minus sine squared x. All right, let's see what happens when we use that. All right, so we're going to simplify that a little bit. So we get 2 sine of x cosine squared x. Here we're going to get sine x cosine squared x. And then we'll have minus sine cubed x. All right, so we have 2 sine x cosine squared x plus sine x cosine squared x minus sine cubed of x. Let's see. Well, let's consolidate these and see what happens. We get 3 sine x cosine squared x minus sine cubed x. But now we really can't simplify much, and it's not all in terms of sine of x. Is there something that we could replace the cosine squared of x with so that we could get it into terms of sine of x? Well, let's bring down our 3 sine x. Now, remember, when you're looking at identities, and you have that square there, you should automatically think of something. Pythagorean identity, right? So what does cosine squared of x equal? Well, if cosine squared x plus sine squared x equals 1, cosine squared x equals 1 minus sine squared x. And then you still have that minus sine cubed x. Now let's distribute. So we have 3 sine x minus 3 sine cubed, should be cubed, sine cubed x minus sine cubed x. Hey, look, you have like terms there. So we have 3 sine x minus 4 sine cubed x. And now it's all in terms of sine of x. Example 6, determining wattage consumption. If a toaster is plugged into a common household outlet, the wattage consumed is not constant. Instead, it varies at a high frequency according to the model W equals V squared over R, where V is the voltage and R is a constant that measures the resistance of the toaster in ohms. Graph the wattage W consumed by a typical toaster with R equals 15 and V equals 163 sine of 120 pi t. In the window 0 to 0.05 by negative 500 to 2000. How many oscillations are there? So we're going to do this one on the calculator. So now we want to plug the equation into the calculator. So we know that W equals V squared over R. Remember that V was 163 sine of 120 pi x. So then we need to square that entire expression and then divide the whole thing by 15. So your equation is going to look like this. Then you need to change your window so that the x minimum is 0, the x maximum is 0.05. I made my scale 0.01. You can make it whatever you want though, as long as it's less than 0.05. And then your y minimum is negative 500, your y maximum is 2,000, and I made the scale 100. Again, you can make it anything as long as it's not greater than 2,500. And then we're going to go ahead and graph. So now we take a look at the graph, and we can see there are 6 periods there on that graph. So that means there are 6 oscillations. So the answer to this problem is 6.